A wind turbine is a device that will convert wind into mechanical movement, which we can use to power a water pump or electricity generator. Now, the power that a turbine creates is obviously dependent on the wind speed, but it's also dependent obviously on the number of sails, the area of the sails, and the angle that the sails makes to the wind. So if you can imagine, if the turbine blades are flat onto the wind is just going to sort of bend it. But if they're at a slight angle, when the wind hits it, it's going to turn the blades, and we can use that for powering things. Now, we're going to have a go at making some very, very simple paper windmills, the sort of things that you can make from the bits and pieces lying around at home, and use that to drive a very small generator to power electronic devices. So we can use our creativity and imagination dreaming up all sorts of different turbines, which is great fun. It's quite good to base it around a simple cork, because whatever design we come up with, it means we can easily push it on and push it off and try different designs. So the cork makes it quite versatile. Now, we've already discussed the sort of classic windmill one. With these particular sails, I glued sticks onto the back to make the sails stiffer, and that makes it more efficient. This one's a rather beautiful one made by a school in southern England, and the children drew round their hands and cut them out, and they've made the sails out of their hands. Our future is in our hands. It's rather beautiful. This one is made out of plastic spoons. So they've arranged the plastic spoons so they're all at the same angle. So when the wind hits it, it spins around beautifully. But a very efficient one is actually a sandcastle windmill. You may have played with one of these on a beach somewhere. And I'm going to show you how you can make one of these now. So we're going to start off with a square bit of card. And card is better than paper because it's a bit stiffer. And you can see that I've marked from one corner all the way over to another corner and done the same there. So I know where my center point is. And then I'm going to cut along within about a centimetre or two from the center. So I'm going to cut along there, cut along there, cut along there, and cut along there. And of course you could use scissors for this. Might be easier. So now you can see that we've got sort of flaps we've made. So you've got 1, 2, 3, 4, 5, 6, 7, 8 flaps. So if you imagine now we get our cork and we glue it onto the center, we can choose one of these two flaps to bend into the center. So I'm going to choose this first one, and we can imagine gluing that onto the top of the cork. We ignore that and we take the next one, the third one, and we glue that onto the top of the cork. And we ignore this one and we take the next flap and we glue it onto the top of the cork. Ignore this one and take the last one and glue it onto the top of the cork. And you can see that we've got our basic sandcastle windmill. Now, I happen to choose this one to start with. If I'd have chosen this one, I'd end up with another sandcastle windmill, but it would be slightly different shape. This one I think you can see is sort of going clockwise. If we just started off with this one, we'd make one that go anti-clockwise. And I think you can see that in here. We've made two identical sandcastle windmills. One, I chose a different flap to start with, and you can see that one goes sort of clockwise, and this one appears to be going anti-clockwise. In the 1830s, the genius scientist Michael Faraday discovered a very simple way of making electricity with coils of wire and magnets. Now I've got here lots and lots of turns of copper wire. Inside here is a magnet. If I spin the magnets, you can see I've connected little bulbs to the end that the bulbs light. So I'm converting the mechanical energy directly into electrical energy with this very, very simple idea, this generator. And we still use this technique today. Now on the back of our turbine, we have a very simple little generator, and it works on the same principles. The turbine's connected via 3 pulleys, and we can choose which one of these we want to use. And these drive the generator. So when the turbine turns, it will spin the generator, generating electricity for us. And we can use the power from these 2 sockets to power the electrical devices. So we've got our little sandcastle windmill as our turbine, and we've got a fan to make some wind to test it out. And I've got 4 electrical devices here that we're going to power. And they're all cheap, easily available, it's almost household objects. We've got a buzzer here, which is the easiest thing to power. We've got a calculator. I've got a little LED torch, like the sort of thing you have in a torch. And finally, I've got a radio, which is the hardest thing, of course, to power. Now, all I've done is taken them apart, taken the battery out, and I've wired into them. so that we can plug them into the generator and to see if we can power them. Now the generator is a DC generator, so one of these would be plus, one of these would be minus. Now which one tends to be plus or minus depends on which way the generator is spinning, and that will be determined by the type of turbine. So if it's an anti-clockwise turbine, it will spin a different way to a clockwise turbine. So what we'll do is we'll use the buzzer, which is the easiest one to get to work, and we'll plug it in and we'll see if we can A, make electricity, and B, find out which is plus and minus, because if I put it in the wrong way round, it won't do anything. So I turn the fan on, hopefully the turbine will start to spin, which it does. I'm going to plug it in here, the red is the plus, the black is the minus. No, can't hear anything. So let's assume that it's making electricity, but it's the wrong polarity. So I'm going to take out the plus and put it into there. That's the plus one, this is the negative, and there you are. So we're making enough electricity to power a buzzer, which is not much. But at least we know that this is the red, the plus one now. Take that out. I'm going to put the calculator in and see if we can power our little calculator. Yes. I don't know whether you can see that. But let's do a little calculation. 9 times 9 equals 81. So that's good. So we've got no batteries here. We're making all the electricity ourselves. Finally put in the LED torch and see if we can get that to light. And yes, it does. Just about lighting there. I can turn up the speed on the fan a bit more and it gets brighter, as you'd expect, because now the turbine's going around even faster, which is turning the generator even faster and getting more electricity. So loads of electricity. Let's finally see if we can get the radio to work. This is a 3-volt radio, so we've got to make at least 3 volts to get that to work. There we have it. Electricity from the wind. If I turn the wind off, the radio stops. If I turn the wind on, we've got the radio. So this is electricity from the wind. Isn't this wonderful? Free electricity. You can learn a lot about the science and technology of turbines just by playing around with paper turbines and windmills. I want to finish with one curious object, because this is a turbine we made which shouldn't work. If you take this out on a windy day, it doesn't turn round. But if you put it on the fan, you'll see that it turns round beautifully. So why does it turn on the fan when it won't turn on a windy day outside? Well, I think the answer is, if I turn the fan off, you'll see that the fan is actually a turbine in itself. So it's spinning. And it's producing, if you like a corkscrew of air coming away from the fan. Now, if you remember from our sandcastle turbines, you can make an anti-clockwise one, or you can make a clockwise one. And obviously one of these is going to work better, depending on the direction of the fan. Now, if we go back to this strange thing, it's not very good as a normal turbine from picking up wind, but because of its shape, it actually picks up, if you like, this corkscrew of air rather well, and that allows it to turn. So I think that's how this is working. So there's so many interesting things you can discover just by playing around with paper turbines.